And this just continues for a lot of July. I was waiting to make this video until the melt ended, but it's just kept going. 2 weeks of temperatures above 1 standard deviation. That's going to be averaging about as much as 2012. So this is a ton of meltwater exiting the Greenland ice sheet. Hey everybody, Jason Box here. I want to make this short video to describe the record-setting temperatures that Greenland is getting July 2023. And this is at a time when global average temperatures are off the charts, caused by the El Nino ejecting that excess heat that the oceans have been taking up. Remember that 95% of the planetary energy imbalance from too much greenhouse gases, it's accumulating in the oceans. The oceans are really the big story about climate because, again, most of the energy is being absorbed by the oceans. Now in the El Nino, it comes out, and we're seeing that here with these shocking new records just smashed globally. And the other part of the story is that we're at an all-time high for greenhouse gas concentrations in the atmosphere. So this global warming thing is very clear in this graphic. And we're seeing the consequences of this with extreme climate events that are just kind of daily now. But to focus on Greenland, we need to consider the North Atlantic. There have been record high temperatures. The typical pattern for sea surface temperatures has been a cold anomaly south of Greenland. This has been persistent, and here in the 100-year temperature trend, the only place on the planet that has been cooling is south of Greenland. This cold blob has to do with changing ocean circulations and probably the excess freshwater from melting Greenland and Arctic Canada flooding the North Atlantic, contributing to this disruption. But here we are today with the marine heat wave south of Greenland. That combined with the flow from the extremely warm North America, it's dragging that heat up to Greenland. It's picking up some heat from the oceans, and that's part of Greenland's melt story this year. To see melting wet snow conditions across the whole southern ice sheet is remarkable. There's even some wet snow being picked up by this satellite measurement here in what we call the dry snow area. These are the count of the melt days, and notice how there's only a narrow area of the dry snow area that has not yet had melting this year. And the southern ice sheet here, which really has high elevations, I'll talk about more, to have melting across the southern ice sheet is remarkable. Just a few weeks ago, we also had record melting conditions across North Greenland, but the story so far this year has really shifted to the south, the southern ice sheet melting. For the whole of Greenland, you can see 2023 here in the red line, and that is rivaling the 2012 extreme melting. On this date, we're ranked second for melting after 2012. And notice how the melt area has been around 1 million square kilometers for perhaps more time than in 2012. So again, we're rivaling the melting conditions at the surface in 2023, rivaling 2012. So we can bring in some of our automatic weather station data here. This place called Die 2, that's 6,960 feet above sea level, so high on the southwestern ice sheet. I installed the original station in 1996, and we managed to keep this equipment running for that many years. 2023, round-the-clock melting several days in July. To have melting at nighttime, the sun does dip near the horizon here on the Arctic Circle, and to have melting at kind of midnight is remarkable. South Dome, higher in elevation, this is 9,490 feet. We had round-the-clock melting around the 8th of July this year. Max temperatures 6.5 Celsius, that's extreme. And so we'll have a closer look at July 8th of this year when that was the warmest day. This South Dome location is very memorable because I installed this station in 1997, and we've managed to keep these measurements running. And there have been problems though, and you can see here what, 20 years later, the station's just getting hammered. It's a extreme climate up there, 9,000 feet above sea level, high winds, and a lot of snow. So the challenge is to keep the equipment from being buried. We have to extend these stations every year or two. We found the equipment June 2021, mostly buried. This was after the COVID problems that did cripple some of these stations. As you can see, they get buried. But we established this new generation of equipment, and South Dome I'm just dwelling on here because that's really where the July 2023 melt anomaly is focused. So these are so-called melting degree days. It's the sum of air temperatures above 0 Celsius, and we have 2023 at record high melting degree days, higher than 2012. And you can see we've got some data gaps here. We know that 2010 was also a very warm year, so that may be up here. But as you can see, 2023 is extremely high temperature for South Dome. So Xavier Fettweis is calculating the so-called surface mass balance. That's the balance of snowfall and meltwater runoff. And for this small, or this area of South Greenland, it's not that small, this green area, the surface mass balance is record low. So the ice sheet has been in mass budget deficit throughout the year when you add these up day by day. And so again, the story for 2023 seems to be so far focused in South Greenland. And so I look here at the integrated water vapor transport. This is precipitable water. It's the amount of water vapor in the atmosphere. And around the 8th of July 2023, it's pretty interesting. So here in the water vapor transport, you'll notice the atmospheric river coming on the 6th of July this year and hitting central West Greenland. We're going to look at precipitation measurements from our weather station network. And notice how South Dome is dry. And that stays like this. So across South Greenland, it's dry during this period around the 8th of July, when, again, this atmospheric river hits central West Greenland and it's delivering rainfall. Here at Die 2 station, again, pretty high on the ice sheet. There's 30 millimeters of rainfall in July of this year. At Saddle, even higher, this is like 8,400 feet above sea level, we have more than 10 millimeters of rain. The rain is really coming on the 6th, 7th of July at Die 2. And Swiss Camp, further north, the rain's coming on the 7th, 8th, 30 millimeters. And that's continued this month. These hourly data are updated to present. There's only a 10-minute latency on these data, so these data are very fresh up through the recording of this video on the 22nd of July. Jar and Swiss Camp. So Jar is 15 kilometers lower on the ice sheet than Swiss Camp, and you'll see similar spike in rainfall, up to 40 millimeters of rain. Looks like about 25 millimeters of rain, an inch of rain in a day at this location at 69.5 north in the Arctic on the Western Greenland ice sheet. So I mentioned earlier that South Dome was dry, and you can see the rain accumulation is very low. It basically hasn't rained at South Dome except for 1 millimeter this month. So the heat wave, these are the ERA 5 data about a few thousand feet above the surface, and you can see from the start of this on the 2nd of July, there's a prevailing south airflow. And this just continues for a lot of July. I was waiting to make this video until the melt ended, but it's just kept going. And 2023 started out low melt, and it wasn't looking like much until July when it really picked up. So here we are on the 8th of July, and this is the pattern that has been south airflow heating, especially South Greenland. Any of the red colors are above melting temperatures. It's again remarkable to see such high temperatures for the southern ice sheet. Here at one of the prom ice stations, we have enough data where I computed the average daily temperature, and here's 2023. So at this location, 1,800 meters above sea level, we have 2023 daily average temperatures above 1 standard deviation, above the 66th percentile. And that has been sustained for what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2 weeks of temperatures above 1 standard deviation. Over here, this photo is Giorgio struggling to walk in the melting snow because this is in the accumulation area of the ice sheet. There's kind of unlimited snow below the surface, and when it's melting that much, you just sink into your thighs. And that's the kind of conditions that you have across the upper ice sheet. It's a lot of wet snow. So the runoff for the whole of Greenland, you can see it starts out low in June, below average, in fact, and 2012 is the green dashed line. 2023 doesn't really get above average until June 24th. Now we're above average, and you can see here in July, the 2023 meltwater runoff is not quite as high as 2012, but it's at a high level. That's going to be averaging about as much as 2012. So this is a ton of meltwater exiting the Greenland ice sheet. Surface melting also punching above into record levels for certain dates. All right, so the total mass balance, this includes the glacier flow discharge. This is the whole thing. And we're actually currently on the 1987 to 2022 average. But we were behind average. We were in a relatively positive mass balance until this heat wave kicks on. You can see this black line is above average, so more mass than average. And that looks like about 50 gigatons more mass than average. But then this heat wave kicks on and we start to converge with the average. The average over the last 20 or so years has been minus 270 gigatons per year. That's about 2/3 of a millimeter of sea level rise per year. And we'll see how this melt season shapes up. 2012, you can see the ice sheet was contributing like 1.5 millimeters just that year. So this is adding up, right? And especially as the melt is increasing with a warming world. So just a few slides on the outlook for the coming days. The Climate Reanalyzer has had this warm anomaly over Greenland for much of the past few weeks. This much we know, and that's the forecast for the coming days. So there's no end in sight. We are in the middle of the melt season, yes, but it's been particularly warm, anomalously warm, and that's why the ice sheet is catching up to average, and we'll see could exceed the average mass loss, which is a pretty huge deficit for the ice sheet, 270 gigatons per year. Again, about 2/3 of a millimeter of sea level rise every year. The outlook for the maximum temperatures has melting conditions, again, quite high on the ice sheet, and the forecast is relatively dry conditions here in the precipitable water. And with all of this melting, the surface has been darkened, and this outlook for clear atmosphere, so the darkened surface is going to absorb more sunlight, and this would be, say, the albedo feedback phase of the July 2023 Greenland heat wave. So it will continue melting at an elevated rate, so that mass loss will probably go below average, so more ice loss than average this year, and we'll just have to see how the melt season rounds out. So thanks for watching this long into the video. It's a pretty rough presentation, but there you have it. Stay cool.